हेलो। हेलो हेलो। हेलो। मैंने व्हाट्सएप किया, थोड़ी है कितने कर रही है। मैंने लिंक भेजी, उसको ज्वाइन करके छोड़ देना। कोई नहीं आया तो एक बात कर लेगा तो ठीक है। कहाँ हो? कहाँ पे हो? अरे कहाँ पे है? अच्छा, वो मीटिंग को ज्वाइन करके छोड़ देना। लिंक लिंक भेजिए जीटीएस कोड तेरे को। असाइंड हो वो। अरे मैं क्या बोल रहा हूँ, सुन तो। उसको नोट कर देना। और आज बचाया नहीं, देख लेना, तुम्हारे भी काम की चीजें हैं वैसे। टाइम मिले तो ठीक है। हेलो। Malay, can you hear me? हेलो। Malay, can you hear me?
Yes, sir.
Can we start? Let's start. So today's last lecture, and the first question is that the oxide that can be used in transparent conductive electrode in solar cell, which first option is zinc oxide, second is indium tin, B and C. Okay, fluorine and indium ductine oxide. One more. Okay, D is also. So why we use this? Question is, if we ask like that, let's discuss. We know the like that FTO or ITO something. Then another layer, ETL layer, electron transport, then absorber layer, then hole transport layer, then upper side contact, AGAU, metal contact. Light incident from FTO side, H nu. If FTO transmit this light inside the material like that here, so FTO should be transparent and should be has high band gap. Why high band gap? Because if
Sir, due to absorption of low,
yeah,
less than EG wavelengths.
so if the FTO is material is band gap is less, then this FTO is also absorbed. So uh, light should be there, absorb layer, reach to absorb layer. That's why this layer should be transparent. Okay, so this material has like that property. Okay,
Okay.
okay, let's move. Which of the following are required for the exciton dissociation in single junction solar cell? Slide is not visible. Okay. Option is presence of interface, large thickness of absorber layer, presence of electric field in the device, cathode and anode of the same work function, and absence of electric field in the device.
Sir, presence of interfaces and sir, presence of electric field.
Presence of electric field. Presence of electric field in the device. So, dissociation. Exciton dissociation should be due to the presence of interference and should be electric field there. Then only dissociation occur. Yeah. Next question is the prime the primary light absorb material is used in perovskite solar cell is R.
Sir, CH3, NH3, lead I3, PBI.
Okay, this is named as methyl ammonium lead iodide. Methyl ammonium lead iodide. Answer is this. Next, next is which of the properties like perovskite materials are beneficial for their use in solar cell? Perovskite material property.
Sir, high absorption coefficient and long charge diffusion length.
And should be also long diffusion length, high, should be high. Okay, so this is short, that's why
सब्जी
not correct.
लेंगे हाँ सब्जी लेंगे क्या लिए
So
सर
answer, yeah.
नो सर
Okay, so today's lecture about perovskite material, third generation solar cell based on. So let's talk about first is what is what is current status for energy and motivation for solar cell. So there we know the conventional energy sources, oil, coal, nuclear gas, like that, but they has limited in nature. And another problem with this carbon dioxide. So we have to find the alternative source. Yes or no? So renewable energy source, wind, hydropower, solar, thermal, geothermal. But solar energy is everywhere on Earth, and simple man or any village person can use access. So that's why is energy is motivated and no pollution, sustainable, diverse application. And our India has the fourth position in worldwide uh, solar energy capacity 60.8 gigawatt, and by 2030 electricity production 50% of solar will be, and 300 gigawatt by 2030 by report authority central electricity. Let's NR. This is the certified agency NREL, National Renewable Laboratory, and technologies worldwide use multi-junction, crystalline, single junction, thin film, perovskite, emerging technology, perovskite like that. So
Sir,
yes,
now it's visible, sir.
visible.
Yes, sir.
Okay. So let's one by one. Single junction. Uh, X-axis is about the year by 1980, 1985 till to 20 February 2022. So this is the efficiency. We can check here like that. Around efficiency in
30.
yeah, almost 30 or so, like that we can check in NRL group which technology has high efficiency and growth by air. This is the about single junction gallium gallium arsenide technique. Then silicon is the first generation solar cell, yes or no?
Yes, sir.
And second generation,
Thin film. Amorphous silicon.
yeah.
Uh,
So
CDT.
six, yes. Let's talk about it. First is silicon technology, crystalline like that. Here we can see single crystal based on concentrator, non-concentrator, multi crystalline silicon heterojunction like thin film. We can see here and respectively indicator within chart efficiency. You can see check here uh, different technology respectively to the growth with efficiency. This is one. And second generation solar cell thin film technologies growth rate with respect to efficiency. You can check and multi-junction, and finally emerging technology. Emerging today's these technology are emerging technologies. Perovskite. Look, in single decade growth rate, tremendous growth. You can see here. Single junction, this is the multi-junction, and efficiency you can see this is around 26% efficiency today our perovskite, not methyl ammonium, formamidinium lead iodide FAPBI3 base perovskite. Okay, so you can check on this website anytime. This is the NREL, National Renewable Energy Laboratory. Okay, so let's talk about perovskite material. APX3 like structure has stoichiometry of perovskite, whereas as the organic and inorganic cations just like that methyl ammonium lead iodide, methyl sorry methyl ammonium or formamidinium or potassium, cesium, like that. B metal has like lead, tin, and germanium, while X halide or anion, chlorine, bromine, like that. Example is MaPbI3. This is the chemical formula. CH3NH3 lead iodide. Name is methylammonium lead iodide. This is formamidinium lead iodide. Chemical structure is chemical formula CH2 whole twice PbI3. And important factor is tolerance factor, which defines our perovskite cubic structure. Cubic, hexagonal, tetragonal. But our interest is for cubic structure, which is photostable. Only perovskite cubic structure has photostable and absorb the light and convert efficiently, give the efficiency. So alpha R equal to RA into RB divided by root 2 RB into RX. What is RA RB? RX is the anionic radii of ABX cation. ABX, ABX respectively. So should be 0.81 to 1 for cubic geometry. Yes. So A is occupied in cuboctahedral like that here, while B is occupied in octahedra central, and X is like that. You can see in picture clearly this like this picture of perovskite. Okay, let's move. Perovskite has like that feature, uh, high absorption coefficient, high charge carrier movability, long diffusion length, high charge carrier lifetime, superpower conversion efficiency around 25.7, and we can tune the band gap, compatibility with solution vacuum fabrication method, low production cost in comparison to silicon, but has long, this is the issue with perovskite, long time stability issue that can be solvable. Worldwide research are going for stability of perovskite.
Sir, why perovskite some uh, uh,
Perovskite,
stability issue, sir? Why, sir? Atom
yeah,
is
yeah,
there. What is the property?
yeah, I will talk about in upcoming slides.
Okay.
Uh, let's show you two first. Let close, then show you. Yeah, here is the issue. Perovskite stability issue due to thermal stress, moisture. Perovskite absorb moisture and degraded, and ultraviolet light. Perovskite has ion migration issue like that ABX3. Halide can migrate in leave the position in a structure. So this is the another and defects, and alpha to delta phase change convert. So many issues like that. So due to this nature of perovskite easily degraded in presence of moisture. Okay. So to I am working on Fa based perovskite solar cell. Why? Ma-based perovskite has a volatile in nature, and that's due to the degradation, easily lead to degrade at higher temperature around above 100 degree, while Fa base, Fa means formamidinium. What is Fa? We have already show you. Fa here, CHNH2 whole twice lead iodide. So, and we can clearly see in another interesting factor, efficiency. Ma base has lower efficiency, but Fa base has higher potential due to the band gap. Uh, Fa base perovskite also close to the SQ limit, Shockley-Queisel limit. Do, do you know Shockley-Queisel limit? Hello? SQ limit. This is the theoretically calculation. Shockley-Queisel calculate, and any single junction solar cell cannot exceed above this limit. This is the highest efficiency of single junction solar cell, around 33%, 1.34 electron volt band gap of material. Okay, so Fa base is around SQ limit, and these are the efficiency band gap can be tuned from 1.17 to 3.10, and absorption coefficient value, carrier lifetime, high diffusion length, and charge carrier lifetime 1 microsecond up to. But perovskite has Fa base has a phase stability issue and fabrication challenge. Important is, so fabrication and stabilize alpha phase pure perovskite film present an important challenge for the whole community, whole scientific community. Yes, let's move further.
Sir,
Yes,
one question, sir.
yes,
Sir, what is the tunability of band gap?
yes. Let's,
Yes, because
yeah,
CID is also tunability of band gap, vanadium and gallium. Gallium, we can tune the band gap.
one
We are
minute.
also tuning the band gap.
APX3. If we tune the halide part, then we can chlorine to bromine to iodine. We can tune our perovskite band gap. Halide, this part is responsible for 4 band gap in perovskite. If we intermix like that, uh, Fa, Pp, I1 like that, I3 1 minus X. This is the pure. If we mix bromine with iodine, interview 1 minus X portion, then we can tune. Or bromine to iodine to chlorine like that.
Sir, tuning means actually doping, whatever
Yeah.
intermixing.
Intermixing, mix compositional engineering.
Oh,
Okay. If we
yes, sir.
mix like that, or uh, vary from chlorine to bromine to iodine, also band gap tune, and intermixing also can tune band gap. So let's working principle understand in similar animation mode. Perovskite like that has a structure, solar cell. First is FTO, then electron transport layer, then perovskite, then STL layer, and upper contact, and below is lower contact FTO, which is conducting layer. You can see in diagram clearly. When sunlight is incident, then exciton excite the exciton. Okay, then electron hole pair generate in conduction and valence band respectively. Then electron goes to the ETL side here, while hole goes STL side. What is role of electron transport layer, hole transport? Let's see. They provide the path for hole STL layer while block the electron. You can see it. like that here. Clear? Role of HTL. Similarly, ETL provide the path because lower the conduction band, so easily electron goes here to here. But upper side, but hole can block. Conduction band is hole energy is higher. Hole is opposite to the electron energy, negative positive. So electron ETL layer provide the path for electron while block the hole. This is the role for electron transport layer. Similarly, hole transport layer provide the path for hole while block the electron. Clear? Yes.
Yes, sir.
Next move further. Then electron goes to the FTO and hole goes to metal electrode side. Then external circuit is applied or we can collect the power. This is the working principle of perovskite. Clear? Here is the IV and these are the 1, 2, 3, 4, 5 major step for working principle in solar cell. First is absorption of light, then excitation of electron, generation of electron hole pair, transport of charge carrier and collection of charge carrier. Okay, then let's compare with silicon because silicon is a commercialized technology. Our perovskite has where is gap. So cost wise our perovskite is half. So our perovskite is cheaper than silicon. Efficiency is comparable, almost equal, but challenge here for commercialization. Silicon has 25-year lifetime, but perovskite has only 1 year due to the degradation nature of perovskite material property. So research are going on this here. Whole committee working here. Improve the lifetime and control the degradation of perovskite. Okay. So any solar cell has cost effective efficiency lifetime. This is the triangle rule for commercialization of any solar cell. So perovskite has light, heat, humidity. Challenge in the presence of light, heat, humidity, our perovskite is degrade. So this is the stability issue for perovskite.
Then, sir, in our subcontinent, light, humidity, heat, and humidity is a factor. Subcontinent area, sir,
Yes.
India and other, there is heat is less. In maybe England or cold areas, it can I think its lifetime maybe increase.
Yes. Yes.
Then parasite
Yes. Yes.
maybe.
Yeah. But research is going on like that. We can encapsulate perovskite so humidity can be controlled and heating is also control. Another research is going on light also. So many researches are going on today in this. If anyone can surpass these challenges, this is
Sir,
yes,
one thing, humidity is a factor, na? Because nowadays we install solar panels on sir water surface.
yes,
There may be some heat absorb the heat in water. Then maybe there is a problem in humidity also.
yes, yes. So Perovskite mm, control humidity via so many polymer can encapsulate the perovskite. Our module has higher much like that much resistance regarding the humidity. So like that is research are going on. Okay,
Okay, sir.
so let's move. So there are the research care for perovskite we already discussed, and overcome the degradation issue. First is encapsulate. Another strategy is additive incorporation, modification of charge transport layer, compositional engineering, implement of novel metal electrodes, and dimension engineering. So many research are going on like that. First is encapsulate, then control the humidity, oxygen presence of oxygen or another gases, then improve the quality and control the phase change like that additive. So modification in chart transport layer like that ETL, STL. So many research are going on to overcome the degradation challenge. So let's how perovskite is deposit. First check FTO, then spin. First is I am spin coating ETL layer. This is the my fabrication styles. Then perovskite coating by spin coating. Then STL coating layer by layer. We grow multi-layer. Then vacuum deposition of metal contact. Then our device is ready. Okay. So
Uh,
these are the two
Sir, one
configuration
thing.
NIP pen. Yes.
Sir, what is the spin coating? Sir,
Mm.
spin coating means, sir,
You
screen printing technology.
no.
Then,
You have a let's. I will show you how this is work. I have a video. Let's show you. 1 minute. Yeah. My slide is visible.
oh, sir.
Let's wait. Okay. Now
Yes, sir. Now visible. Visible, yes.
you can see in video there is a machine which rotates the substrate FTO. I am putting here FTO. Uh, oh, shit. Maybe internet issue. Let's again start. You can see this is the spin coater machine, and here is the FTO. You can see on FTO electron transport layer already coated, and now I am coating the perovskite. Drop the perovskite. I have dropped yellow light liquid. Then rotate the FTO around
Yes, sir.
4000.
This is spin.
This is known as spin coater and spin coating
Okay, sir.
tool.
Okay, sir.
Okay.
Yes, sir.
Okay. So this fabrication at IIT Kanpur. So let's come back with our Okay, spin code. Hmm. So like that we can fabricate perovskite easy. And characterization. Any research cannot happen without characterization. So characterization is important step for research. So X-ray based characterization like XRD, XPS, UPS, SRFs, and electron based probe. What is a probe? Means X-ray is incident on the film, then output are collected like that. X-ray reflect or scattered, then detector is there and collect the output and tells us uh, ha- what is the happening here there, what is the nature of the perovskite like that. Electron based probe like that same time. And tip base means contact if tip sense or tunneling current may be there. So STM FM technique for tip base, and another is light base like that visible or infrared base. So these are the techniques. And X-ray base absorption spectroscopy. Let's read here what X-ray absorption spectroscopy measure the change in response of system of function of incident photon energy probing unoccupied density state. The X-rays spectra can divide into two categories: X-ray absorption near edge, named as XANES, and extended X-ray absorption fenestraction. Can refer to region edge absorbed it sensitive to oxidized state. This can be sense oxidized state or coordinate with environment. On the other hand, extended X-ray refers to oscillation in the absorption coefficient starting approximately 50 K as and extended up to the several hundred due to the short means free path of the photoelectron associated with the technique probe the immediate neighborhood of the absorption atom. Modeling provide the information about the coordination number atomic distance of the absorption atom. So this is the use for coordination, and above is oxidation state and coordination environment. XASH can be probed local structure change within the perovskite material as well as the degradation. And similarly, XRF, X-ray fluorescence. These techniques are based on nano or micro X-ray beam that can be sampled to obtain a 2D map. X-ray fluorescence extract photons from the element in the sample are used to produce a chemical. Ray beam are collected producing image which change charge collection contracts. Both techniques are bulk sensitive. This is used for bulk to X-ray penetration. The combination of these two techniques allows to correlate chemical distribution with change collection efficiency in perovskite. Similarly, SEM, scanning electron microscope. SEM is a tool study the range material from micro to atom scale. Through image produce the interaction between electron beam and the sample surface. When electron is highly accelerated, electron is incident on the surface, then interact with this electron and produce output like that a secondary electron from the atom, then are collected from the detector and produce the image. During the interaction, electron beam surface diffraction type of single are generated, such as scattered electron, secondary electron, and characteristic X-ray. The base scattered electron and secondary electron are responsible for detect the contrast in the composition of the element and topographical morphology information. This is the use of BSE and ES from the surface sample respectively. Further X-ray analysis provides about the element composition of the material. SEM is a technique of a large depth of the field and wide field view enable the spatial resolution and hence being an important tool for the in situ or operando studies. The sample must be solid or the requirement is sample should be solid or conductive. Moreover, high electron flux could be cause the sample degradation in long in situ experiment. So flux should be low for degradation if our sample is not stable in presence of high electronic flux. Similarly, TEM transmission electron microscopy. This is you can see picture. Let me- Here is the same TEM image. So this is like that the same. This is the TEM. TEM transmitted electron are collected and detected, while the in SEM reflected or secondary electron emitted or X-ray are detected. These are the difference between SEM and TEM. Okay, and
Yes.
other is tip base. When the tip is closer to the sample and there is a voltage is applied, uh, also is connected with the voltage tip, then electron are sensed or tip can be touched like that scanning. So this is the like that measurement for tip, and another is when light is incident on the sample like visible or infrared, then from the detector we can collect the information. Okay, so like that time SAM, scanning STM, KFM, there are the explanation you can read. I will send you this slide upload on the, and if you want to more information please search like the technique how to SAM is working, you can search in Google. Okay, FTR, IS, Raman photoluminescence, transient absorption spectroscopy, UV visible, ultraviolet, terahertz, and IV measurement. So let's move the another question. The reason, so previous slide is regarding the perovskite technology. What is the structure of perovskite? How is working principle? And what are the characterization should be done. Okay. So next question is the reason for using soda lime glass as substrate for in the fabrication. Solar cell is R. Why is used soda lime? These are the options. Please answer.
Sir, improve the film texture, reduce the surface passivation.
Yeah. So answer is sodium helps the surface passivate the defects and improve the film texture. As are already discussed in class, you can see. There is the deposition on sodium lime slabs and helps to surface passivation. Okay, and another is improve the film texture. Let's move on another question. Which of the following is our critical issue with dye synthesized solar cell (DSCC)?
Sir, B and D, liquid dye and electrolyte degradation.
Liquid, they are in liquid in nature and electrolyte degradation.
Degradation.
Yes, this is the issue with DSCC solar cell. So, sir already discussed in this class. Yeah, next question is bulk heterojunction solar cell has superiority over bilayer solar cell due to bulk hetero organic solar cell.
B and C, beta dissociation of excitons and interfacial contact between donor and acceptor. Beta.
Yeah. So contact is better, better interfacial contact between donor and acceptor. Also donor and acceptor like that here is donor and acceptor layer. So here is the working
It's a
principle.
single junction.
Yeah, yeah. In multi-junction there are this is the single junction. I have to upload. Okay, okay. So multi-junction there are so many layers like that. Electron transport layer, hole transport layer. Also there here. So and another is better dissociation of excitons. Why? Because is transport easily due to the ETL or HTL layer. Selective charge carrier layers. And another question is the starting source of the sulfur for the window layer deposition in copper, indium, gallium, selenide solar cell is a option is this. Please answer.
Sir, H2S.
S2S. No.
Sir, no, sir, number one, SCNH3.
Yeah, yeah. So
This one.
uh,
Yes, yes, yes.
yeah, sir is already
Yes, sir.
discussed in class. You
Sir,
can
yes.
silicon salt
Yes.
sources is this.
Hmm.
And another is please answer. Coming back 1 minute. Yes, answer.
Sir, dye center low band gap. Light dye center is,
Solar cell. Why low band gap?
sir, very thin.
And thin band gap not depend the thickness. First of all, you should clear. Any material has like that or like that a thin, ultra thin, like that. Not in nano range, but appropriate range.
Because the ruthenium has lower than the medical cell used. Ruthenium.
Also, should be any solar cell material has low band gap. If has low band gap, can absorb light in from three like that lower to higher range and utilize the whole spectrum. Yes or no?
Yes.
This is the fundamental question. Okay, so low band gap is the region. And which of the following is used as the dopant polypropyl
Very
polypyrrolate
efficient
organism? Okay,
transport.
okay, APCl3 for the dopant, and this is SiO3 APC. You have and conductivity like that as a much higher conductivity. Okay, and the upper electrodes used in DSCC solar cell is R,
So nano TiO2, nano SNO.
not
SNO2 zinc, zinc.
ZNO.
Okay.
So here is a nanostructure TiO2 ZNO2.
Okay. Okay,
And
sir.
our DSCC solar cell how is working? Let's see. First is absorb the light, and first step H nu is light absorb and excite the dye, and after the excite dye with TiO2 create the electron and positive with dye. This is step is injection process. Okay, third step, and these electron and counter electrode R gives TiO2 and back electron and electrical energy, and we capture the electron and regenerate the dye. These are the mechanism for DSCC. Sir, already discussing in class. Yes. So
Yes.
please remember, please learn what is in exam can be asked like that. What is the mechanism of the DSCC? Please introduce one by one step. Okay. So this is all about today. Yes. In any assignment, do you have problem?
Sir, already completed. Sir, assignment 5,
Yes.
question number please just check. They will update all except assignment 5, question number 3.
I
Can you
have
open assignment number 5, sir?
okay, okay. 1 minute.
Just assignment number 5, sir.
Okay, okay. Assign number 5. Let me find it.
Sir, see the question number 3.
1 minute, wait.
Yes. Question number 4.
1 minute, 1 minute. I have to find
Okay, sir.
assignment 95. 5.
5, 5.
Okay. So, assignment 5. Those are no, no, no. Continuous piece of this. Where is this? Do you have like this assignment or this is
Yeah, this
question?
one, question number 3.
Which
3.
of the following method can be employed to increase the quantum efficiency in the eliminate a p-n junction diode? This is the question.
Yes, sir. Yes, sir.
What is the problem?
Sir, I think option E also this increase the cell width because SAR's lecture one slide is there. It's already sir written
One
surface
minute.
passivation light trapping.
1 minute. 1 minute. Which of the following method can be employed to increase quantum efficiency? So, in aluminum PN junction diode, increase the cell width. Uh, when cell width increase, what will be happen? Only the absorption can be improved. Yes.
Yes, yes,
If the one more thing is that like that, if the absorption, do you know diffusion length?
yes, sir.
If the cell has too much length, width is too much. So what happens with the charge carrier? If diffusion length is less than the cell width,
It will not reach to the junction. Sorry, electrode.
so quantum efficiency, then this case quantum efficiency
Decrease. Decrease.
decrease.
Decrease. It will recombine before. Okay, sir.
So maybe not correct, should be not correct. But uh, we have to write like that the diffusion length less than the cell width. Like that, we have to improve this option. Yes, obviously,
Okay, sir.
if the cell width is increased, then absorption is increased only when uh, electron and photon generators should be go to the respective electrode. Diffusion length is is comparable with the cell width. Only that much level we can increase the cell width.
Yes, sir.
Okay, so
Okay, sir. So rest one question was wrong. They will update. They were update yesterday.
okay.
I mail update.
I
Yes, sir.
already told to
Yes,
now.
sir.
So today I got the
Already
last.
updated, sir. Question no.
Yes.
Assignment number 7, I think.
Today I
They will
am.
update.
Today I already get this mail. There is the regarding the assignment revelation for March. So do your exam 26.
Yes, sir. Tomorrow.
Okay. So best of luck
Thank you,
and
sir.
please go. You can check the slides. Uh, my and other TAs. Only
Yes, sir.
you have to follow only the slides, not the lecture, because lecture take much time. If you not understand, then go to the this time on the lecture
Video. Yes.
videos which are available in YouTube and also in. Do you have access?
Yes, sir.
Okay.
From the portal, anyone can access, sir.
Okay. So there is a access link. So
Yes.
thank you for today.
Yes, sir. Yes.
Oh, so let's stop the today lecture. Thank you and best
Okay,
of
sir.
luck for your
Thanks.
exam. If you have
Thank
any
you, sir.
doubt, you can email me anytime.
Yes, sir.
Okay,
Yes, sir. Thank you.
thank you.